So my topic of research, of interest is energy urban planning. And I'm more focusing on a transition to decentralized energy in cities. And I'll talk a little bit about it during the presentation. But the idea is that we have traditional grid that we all have in most countries in the world, and we have decentralized systems that are new trend, a new thing in both energy field and planning field. And this is actually what I'm looking at in my research. I briefly talked today about my professional background, then I moved to framework of energy planning. I would like to introduce the energy planning in general as a field, if maybe someone not very familiar with this topic. And then I move to the area of my research and talk a bit about my research and show some result that I'm working on. So a little bit about my professional background. So I finished my undergrad degree it's actually a specialist degree, it's a 5-year degree in Russia. I'm from Moscow, and that university that I finished was State University of Land Use Planning. And my official title was Engineer in Land Cadastre. So we don't have planning department, we don't have planning as a field in this university. We have it breaking down to several categories. So one of these categories is land cadastre. So there I worked with mostly technical stuff and legal things. So with land use planning, it's remote sensing, geodesy, GIS, and environmental planning. So I worked as a intern and environmental planning company after that as a GIS analyst, and I worked focused on the gas geochemical analysis of soils. And after finishing this degree in State University of Land Use Planning, I had a choice where to go, to the municipality and work as a land cadastre engineer, mostly work with papers, or do something else. And then I found that Rosseti is Russian grids company. It's the largest energy transition. So they transit energy through the whole country. So largest energy company in Russia. I found that they need a person who will focus both on energy and land use. And I started working there. So I spent half a year working there with land and its properties, basically as a lawyer, something like this, like lawyer in land cadastre. But then I found that there are a lot of other different interesting projects, and then I make a transition to the energy field. So I work with smart grids, I work with charging stations for electrical vehicles. It's a big program in Russia going on now. And we were basically those 10 people who started this program. It's still ongoing process. Then I work in the field of energy efficiency, and we created this testing facility for high-tech power grid equipment. So it was our main project. And then in 2017, I started my PhD program in the University of Illinois, Chicago, where I have focused on energy urban planning. And last semester, I became a PhD candidate, which means that I passed all my qualification examination, and I'm ready to write and finish my dissertation. That's actually what I'm doing now. And also, I'm working in research and teaching assistant in the Urban Data Visualization Lab, TRC of GIS. Okay, so now a couple slides about the energy planning and its framework. It's important to understand how I get to this point, because energy planning is not something traditionally recognized in urban planning. So sometimes energy planning is a very different field from urban, and I want to talk why they're connected, why I feel that they're connected. Let's start briefly from the very beginning, from the population. So we know that the population is growing highly since 1950s. The trend of growing population is super high, almost exponential, and urban population is in 2018, so so based on the data that United Nations have, is 55%, so a little bit more than rural. And in 2008, it was a big switch between rural and urban population. Previously, it was more rural, and now there is a huge migration to cities. And the projection of the United Nations by 2050 is that the world will be 2/3 urban, more than 60%. In this case, the energy, especially energy in cities, will become more important task because as many people are coming to cities, more energy we need. So there are limited amount of resources which cannot sustain such a rapid growth of economic activities and population. This means that we need to switch our system a bit, or absolutely change the structure of the grid to make sure that it can accept these switches and these changes. And even though the distribution of urban planning and rural population and rural are almost the same, 55 versus 45, the urban areas are responsible for 70, 75, 80%, depending on the area, of global greenhouse gas emissions. So it's not 50% as the population is. It's much, much higher. And so approximately 75% of the world's energy consumption is assigned to the urban areas. So it's not only greenhouse gas emissions, it's also energy consumption as a raw characteristics. And also there's a research in US Environmental Agency saying that about 40% of energy is consumed by buildings. And it's much higher than other two. It's higher than industrial and transportation. So we can think about the factories like industrial, that they consume much more energy and they pollute much more, but actually no. So buildings in their production and construction and usage, they consume much more energy than other sectors. And the framework for my research and for research a lot of people who are working on sustainability and energy is 17 United Nations Sustainable Goals. So they cover a lot of planning and not planning things. So they could include everything from the nature to the health to the education. But I feel that my area is lying in these two. And I try to frame my research within these two goals of sustainability. So it's goal number 7 is access to energy and increase energy efficiency and the use of renewable energy. And goal number 11 is sustainable cities. It's adaptation to climate change, resilience to disasters, pollution, and waste. So I try to frame my research within these two. And combining these two goals, goal 7 and goal 11, basically it's combining energy and cities. And from there, we can understand that the urban environment has a key role in the implementation of the Sustainable Development Agenda and achieving energy targets. So the combination of this goal 7, goal 11 gives me the framework of my research. Okay, and here we can see that energy is connected to a lot of topics in urban planning. So all these topics on the right, it's land use, it's zoning, architecture, transportation, water, landscape architecture, environmental protection, nature design, and utilities and infrastructure planning, and even other topics that are not covering directly from the planning, like jobs, economic developments. They all somehow connected to energy. We can see the connection between energy and each of these fields. Like energy in architecture, it's energy efficiency, it's energy efficient buildings. Energy and land use, it's design of districts, energy districts. So we can think, if you feel that your research is located in one of the areas on the right side, you can clearly see its connection to energy to the left side. And finally, recently, energy recognized as an important factor in planning. So it was recognized that planners can and basically should affect energy consumption. And in America, there is an American Planning Association. It's big organization focusing on all types of works as plannings do. And in 2004, they developed a policy guide on energy. It's developing, and in 2012 it was an update. And it said that comprehensive and general plans should include land use policies crafted to reduce energy consumption. So basically, they officially say that energy is connected to urban planning. And so now energy is becoming its own planning specialization within the field of urban planning. And I'll just briefly touch on this. So if you think about urban planning and what can I do in energy field? So you have this question, because if you're working as a planner in a municipality, you briefly understand what you should do. But if you say that I'm going to be energy planner, there are three types of plans that they are slightly different between each other, and there are three categories of energy field that you may want to work on. So it's energy plan as a first, and the goal there is to reduce energy consumption. So it's not connected to greenhouse, it's just connected to save the energy. And the metric there are super technical. It's kilowatt hours, it's therms, and common theme there are energy efficiency, energy conservation, introducing renewable energy, basically operations of the energy systems. And climate plan is a little bit different. So it's focused on greenhouse gas emissions and climate change. So there you say that, for example, you are following Paris agreements and you're reducing CO2 and reduce your ecological footprints. And common themes there are transportation, waste, and buildings. And another plan is sustainability plan. And the goals there are super different depending on what city wants. But everywhere it's connected to these three characteristics of sustainability. It's social, it's economic, and it's environmental well-being of the city. So the metrics could be very different, and themes are also could be different, and they basically include everything from the previous slide I had on the right side. So it's connection of energy with everything else. Oh, here is just some examples of the plans that I found very good. And there you see that they're different. So it's Minneapolis, it's in the US, not far from Chicago, energy plan. It's a very huge document. Actually, it's about like 300 pages, and it includes all about the energy development. So Minneapolis plan is a very good example of energy plan. Santa Monica is a city in Los Angeles in California. They have sustainable city plan, very good too. And you see that they're covering, even from the cover here, they're covering a lot, even like culture, even like open space areas and like economic development. So they're covering a lot. So sustainability could include a lot of different tasks. It's what Santa Monica defined by themselves. And on the right side, it's Öresund region. It's in between Denmark and Sweden. And it's not even an interesting thing here that it's strategic energy planning, not only for one country or one city, it's even for the region. So they talk about both side of the Öresund in Denmark and Sweden, and they try to create a central system and central energy planning in the whole region. I actually have these plans, so you can find them. They're publicly available, or if you want, I can send it to Marian, for example, to share with you. Okay, and so everything before sounds good. So there are energy planning specialization, there are some plans people are doing, but what the problem, you may ask me? And I can say that now still energy planning is not recognized as a part of urban planning field broadly. So we can see it from the literature, from the research papers. So energy literature in general doesn't consider urban issues, and urban planning literature doesn't consider energy issues. That's a good example I found from some statistics that in Energy Policy Journal, it's a very big journal in energy field, since 1973, so it's almost like 50 years after that the journal starts, it's only 300 papers have the urban in their topic or in their abstract. So this means that in energy journal, the main energy journal, people are not publishing about urban planning. And the same is from urban studies. So they have history of 50 years of this journal, and it's only 20 papers, it's actually 26 papers, mention energy or electricity in their abstracts. It's mostly in the field of transportation. So it's just a couple of papers touching on the energy systems and transportation. So you can think that during the 50 years, it's only 26 papers. So it's very, very low numbers. And Environmental Planning Journal, it's another big journal in the environmental field. It's only 10 papers in the last decades mentioned the energy. So energy-driven urban practices were relatively invisible in both urban planning and urban policy and urban planning research agenda. And so resulting in this lack or clearly defined framework and methodology create these barriers for urban energy planning. That's why it's a relatively new topic, even for planners who work in the field a lot. Urban energy planning is something like brand new. Okay, and here I don't want to go deep in the really like big field of problems of why it happened, but I just want to briefly mention three of them, what we with my colleagues are trying to find the most important problems, and we found that these three are the most important. So energy planning has been carried out in parallel by municipalities, by different organizations and utility companies, or, which is more common, not here in the US, like for example in Russia, it's not carried out at all. So there's no field of energy urban planning. So nobody is doing this. And why it's happening? It's because of the first reason is lack of expertise or knowledge or training. So there is no formal education on this field. For example, in Denmark, I think it's in Albert University, they have specialization energy urban planning, so Master of Energy Urban Planning, but it's very few universities who actually do this in the world. And in US, there are no universities doing this. And second point is overlapping scientific, political, administrative complexities. So basically, nobody knows what to do. Who should take care of this? And number three is input is often lacking the capacity to enforce implementation. This means that even if their plans are done, it's very popular in US, this type of problem. So even the plan is done, it's never implemented. So plan is ready, it looks good, it's accepted by municipality, but nothing from there is happening. Okay, so we framed the energy urban planning as a field to understand that there are some complexities and some uncertainties out there. And now I'll talk about my area of research, which is a little bit, so it's not included the energy planning as a planning. So I'm not creating plans, but I'm more thinking about how these plans could be implemented more in the urban planning field. And so here is just frame of my research. So it's how I frame where I am. So I have two main blocks. It's energy planning and urban planning. And they're not connected a lot. So energy planning is physical structure of the grid, energy market, policies. It's what energy engineers do. So here in our university, in the University of Illinois, Chicago, there is a separate field within the civil engineering named Master of Energy Engineering, and they're doing this stuff. So energy engineering is subfield of energy planning, and it's mostly covering by them. At the same point from urban planning, I feel that there are three main blocks that I'm focusing on. It's city design, so it's more spatial structures of the city and GIS analysis including there. And then it's environmental science. It's because here specialization of energy is framed within the environmental field. So because the goal is to decrease CO2, it's to decrease greenhouse gases. So that's why it's connected to environmental a lot. And third with architecture is how buildings should be constructed actually. So how this fields, how architecture, what role plays architecture in urban planning. And as a frame of this is complexity science, because these two fields, urban planning and energy planning itself, they are super complex fields. So we cannot say that energy planning is easy. I understand this. It's complex, and combining these two fields create a superstructure, and which is super complex. So complexity science is something that framed my research. So the place of my research is here. So it's basically technological design and policy aspects of urban systems within the framework of transition to decentralized energy electrical systems. Yeah, in simple words, my research focuses on decentralized energy systems in cities. Just briefly want to mention that here is a traditional grid. It consists of generation, transmission, and distribution and consumption. So it's 3 blocks of the energy systems. And here is just what I found interesting for me in each system. So in generation, it's more renewable sources, on-site generation, generation closer to customers. And within the transmission, it's reduced losses due to large distances and blackouts caused by this. So sometimes we see that generation is located in 1,000 kilometers from the consumer. So it could be located even in other countries, even in the other continent, and transmit for super long distances, which is not good because we have these losses. And the consumption part, what I found interesting for me is energy efficiency design of buildings, district design, because it's important to design not only buildings itself, but in complex within the districts. So how buildings are connected to each other, how they stand together, how they shade each other, how the vegetation is, so where the trees are located. And also the consumer behavior, so how we promote the energy efficiency and how we promote to save energy, how we promote to switch off the lights. So here's more policy type of things. Okay, so here's just generation 2. I don't want to go deep to this production, but I just want to focus that now in US, so the 3 more popular source of energy is natural gas, coal, and nuclear that you can see in the orange graph. So renewables are really super low. So still we have this. So there are some hydroelectric, there are wind, solar, but still the percentage is super low now. So it's about, I would say 10% without hydroelectric and maybe within 20%. Now it's better. It's data from 2018. So now they have a little bit more wind, but still it's pretty low. Even the shift, we can see that after 2010, the coal is decreasing. So the brown on the right, but still it's not gone. It's still there. And the strategy is to move from coal to natural gas. Natural gas, of course, is better, but it's not the perfect usage. So the usage of coal is being replaced by natural gas, but still it's about 1/3 of the whole generation, and total share of alternative plants is super low. Here are some strategies that are popular around the world and they're trending now. So if you think about the energy urban planning research, you might think about one of these subfields. So the first is decreasing consumption. This is easy. It's programs of energy efficiency, efficient design of the buildings. For example, LED lighting. So we know this energy efficiency light bulbs. So they can save really a lot of energy. So just switching to them will give us some hope in the field of energy efficiency and design of buildings. Also, we need to design buildings with nice insulation, in nice windows. Everything should be efficient there. And it's a problem in the US actually that buildings are not well insulated. So even in the cold regions, as here in Chicago, for example, it's pretty cold winters, the buildings are still constructed from the light wood, so they're not well insulated. So it's we lost a lot of energy from this. Second is modern renewables. So we know this, it's introducing renewables into grid, it's wind power, it's solar panels, it's even solar heat districts. So there are a lot of them, and it depends of what area you are. You can use different sources of renewable energy. And storage systems, and this is a good one because now it's what is changing in energy field. So storage is batteries. They're becoming cheaper, and they're becoming more and more useful. So like Tesla, they're creating these batteries that are much cheaper than they were in like 2017, for example. So there is a big hope for this because all this wind and solar cannot work without storage very well, because we don't have wind always. This means that we need to store some energy when there's a huge wind capacity, and we need to store it somewhere and use it when there is no wind outside. And for number 4 is decentralized power grid microgrids. Is what I'm focusing on. And it basically includes all 3 components. So it includes a program of energy efficiency, it includes introduction of renewables to the grid, and it includes storage systems within the system. Yeah, and microgrids, it's just decentralized. So decentralized power grid includes more flexible technologies located closer to customers. So if you think about solar panels on your roof, it's decentralized power system. And usually these systems include generation. It could be solar, it could be small wind turbines, and energy storage. It's like batteries, fuel cells. So there are different types of storages. It's not only like battery, like located in your car. It's could be even like fuel cells, which is more complicated things. And microgrids, it's another world to the decentralized power grid. It's physical incarnation of distributed energy sources. It's group of loads and resources that could be connected to grid or disconnected for remote territories, for example. And yeah, so it's just almost the same, decentralized power grid and microgrids. And here is just a simple example of what microgrid looks like. So here is on the left side is connection to main grid. So why it could be connected or not? So sometimes microgrids should be connected, because if they don't have enough solar or wind or whatever they use, they can be just turn on the switcher and get energy from the grid, basically buy it, or sell if they have too much. If they have too much energy, like super windy days, and they don't need this energy. For example, if it's like May, they don't need too much energy they usually need more energy in winter and summer, but they don't need a lot of energy in spring, so they can sell it to main grid. Otherwise, it could be disconnected from it. And microgrid includes this all component that I mentioned, and also microgrids could be connected to other microgrids, and or not still. And the main component is control. So there is maybe you heard about concept of smart cities, smart systems, smart grid, and this control in the middle is actually smart system. So it should automatically say when to produce energy, where to store it, like where to give it, to what buildings move it. So these smart controllers is a big deal for the microgrid. And why it's important? So there are a lot of benefits of microgrids. So it's increased reliability of the grid because it's connected closer to customers, and increased resilience and ability of grid to recover. For example, if something happened, it's much easier for an engineer to walk 100 meters than to go 100 kilometers to some point where the wire is on the ground. So usually prices are lower because there is a smaller system, so smaller distances, cheaper to control. So to buy the control, it's might be expensive, but usually it's the overall price is cheaper than just buy energy from traditional grid. And then there are independent producers, so basically consumers of energy, you and me, becoming prosumers. So it's productive consumers, so consumers who are producing energy. So because solar panels on your roof, so in this case you produce energy and sell it, so you're in an energy market. So there are also environmental benefits because this clean energy, more cybersecurity. Its system is small. It's just safer to keep the small system than a huge system. And overall improvement of population. Usually there are some measures of how decentralized energy affects the well-being of the population. And there are several research saying that the improvement and overall quality of life is better in these small communities. Okay, so taking this, there is a real need to bring it to communities. Because now it's usually installed in some universities, hospitals, and if they're pretty well introduced to the communities, but they're not very popular topic. If we think about the good neighborhood, we're not starting thinking immediately about this, but I believe that planners should have this energy-based approach in their planning system, and they should take the energy into account and bring this to community is an important thing. And there is a lot of knowledge about the technical point of view, how to create the microgrid. So it's tons of research. Everybody knows how to actually locate a controller or producer or like wind turbine. So there is no problem with this. The problem is how the policy should be adapted. So how the urban planners should promote and how they should teach their neighborhoods when they're working about these issues. And the complex system approach here is important because it should consider engineering as urban planning and design and policies. So yeah, the main question in my study and in studies of people who are studying decentralized system, what could be actually done in cities to make microgrids more widely used in communities? This is an open-ended question. It's not what I can to respond right now or maybe in a few years, but the goal of my dissertation, my research, and maybe post-dissertation even, to respond to this question. Yeah, and then a couple of slides, I'm going to wrap up what I'm doing now and what I've done so far. So my first part of the research, it's basically about my dissertation itself. So I took the initial stuff is to analyze what's going on in Chicago. So I'm going to look at the Chicago as the case study of Chicago because I'm here. Why not to use opportunity to work in the city when I am? And so I took the Chicago energy benchmarking data. It's actually open data. You can just type in Google Chicago energy benchmarking data. And the problem with energy data is huge. So it's not accessible. It's super privately closed. So you will feel difficulties to find the data. And this is an open data source. So if somebody is interested to look at the energy data, Chicago energy benchmarking data is a good case. And it shows the total energy consumption for big buildings. It's more than 4,500 square meters. And it's about 3,000 buildings reported to this report in 2018. The bad thing there that they haven't updated it for the 2 last years. So the most recent data is from 2017, and we're really waiting for the new data. So hopefully it will be available soon, and we'll see. And then I took that data and then I collected manually data about buildings and surrounding built environment. So I just broke all buildings in cities to these 6 categories. It's high-rise, mid-rise, and low-rise. And then I looked if the building is attached to another or detached and standing alone. Yeah, and this is important to do to understand the consumption part. So there is a consumption and distribution part of the energy. And this I do for understanding the actually consumption of the energy. And I finalized 400 buildings as a case. So I'm going to finalize it at some point, all 3,000 buildings, but yeah, it's still in process because I'm trying to automate this process, maybe using GIS, maybe not, but yeah, I'm going to collect the data. And here is just a simple random selection of the buildings. So I selected 400 buildings and did some machine learning random forest analysis of the important variables. And I got the results that low-rise buildings, so it's purple and brown on the graph, consume much less energy than the high-rise buildings. And the interesting thing here is low-rise buildings are almost everything old, so it's not new buildings, because in Chicago there are a lot of skyscrapers and they're all high-rise, and basically all new, fancy, cool towers. They consume much more energy per square feet than low-rise, even old buildings. So in this case, interesting outcome here for me is that low-rise, this classical 3 floors buildings, which in the right bottom corner, they consume much, much less energy than these fancy big towers in the downtown. Yeah, and here's just case studies. So I just want to say that there are some implemented microgrids, or there in implementation, that I'm going to use. So I basically, here's my first step. I analyzed urban form and see how buildings are affecting consumption. Then I looked at case studies. Actually, this is structure of the grid. Here is the grid from Chicago Bronzeville. It's another university. It's Illinois Institute of Technology. They have their own microgrids together with the city. It's not ready yet. So they have a microgrid in Illinois Institute of Technology, but they don't have it connected with the city. And also there are 2 microgrids in New York University and Fort Collins. And there are 3 case studies that I'm going to analyze and get the structure of the microgrid from there. And my current work, what I'm doing actually right now is modeling, because for policies, the best way to test policies is to do pilot versions of it. But create pilot version of microgrid is super expensive and without modeling. So modeling is the best option for this. And I have 2 methods. I don't have results for this, so it's in process. I have some preliminary results, but yeah, maybe it's another talk for another time. But I'm using basically two methods that could work with this complex, could work with complexity, basically. So first is agent-based modeling. It's a modeling bottom-up. So it's measure the behavior of the whole system based on the behavior of individual agents. So individual agent is a building, it's solar panel, wind turbine. So it's individual, and we can see that they're interrelations. And system dynamics, it's kind of vice versa. So it looks at the whole system over time and see how the components work within each other from the whole system. And the final slide, just last thoughts, that transition to decentralized energy is a trend and game changer now. It's a lot of papers coming basically every month. And the energy system is under a big transformation. So we're moving from big utilities that we had before to private residents as producers, and energy is coming from fossil fuels to renewables. And there are a lot of strategies. I know that in European Union, they have a strategy, I think it's 2040 strategy of energy. And in the US, they have their plans, especially with the new administration, probably the next year. So it will allow to develop energy systems and urban systems simultaneously, because it's important to combine. Since we're creating new energy things, we need to adopt urban systems too. And key change is technology, storage technology, and renewables. Since they will be cheaper, it will be more wide use. And so the question is how decentralized energy could be implemented. As I mentioned before, this is an important question, and we need, as planners, I think, to work what should be done in cities to make sure that the technologies are worked for us. So yeah, that's it, and thank you very much.